Okay, this will be part 4, and it should be pretty short. Okay, so we're actually going to do one more thing that I didn't have on the previous list, and that's talk about how we would calculate sample size required. You probably have a homework question or two about this, and the way the book tries to explain it is not great because we're going to use a program on our calculator if you have it, or I've posted a file in the content. It's an Excel file that you can use. You type in the 3 numbers that you're given, and it tells you what the sample size needs to be. So we're going to talk about that in this quick video. All right, so for this example of coming up with and finding the sample size needed to conduct our own sample, then we're going to use the same data that we had with a previous video. So we're still dealing with 16 to 17-year-olds living in the United States who say that they use their cell phone to text while driving. And we had we found these two values. We said that X is 272 and that N was 800. This is from a previous study. What we're going to do is calculate how many people should we survey based on what results we want. So we want to, based on the confidence level that we want and based on the margin of error that we would like to have, what should our survey or what should our sample look like? All right, so here's our question. You wish to conduct your own study to determine the proportion of 16 to 17-year-olds who text while driving. What sample size would be needed for the estimate to be within 3 percentage points, so that's telling us our margin of error, with 99% confidence, that's going to be important, if we use the point estimate obtained in Part A. And so that's why I went over what we just did. We said that p hat is x over n, and we were just reminded that x was 272 and n was 800. And I can actually just put that in. I don't have to come up with the decimal. If I don't remember it or haven't already done it, I can just type in that fraction. Now I'm going to go to our next page so that I can show you how we would do this with the Excel file that you have available in Momentum. If you have a TI-84 calculator from the school, then you should have a program called SSProp on your calculator. I do not have it programmed in my emulator, so I can't record me going through the program on my computer and take a video of it. But basically, when you start that program, it's going to ask you for 3 values. You put those 3 values in, and it will tell you your sample size. However, if you don't have that calculator from the school, or if something's wrong with the calculator programming, which sometimes that will happen, so people will get in there and end up deleting things, and then the program won't work, you can go into Momentum, go to the content section, open up chapters 8, 9, and 10, and there's an Excel file. When you open that Excel file, you'll see what I'm about to show on the next page, and you will only be able to type in to 6 boxes. 3 boxes for population needed for a sample size needed for a too many P words, a proportion, and the sample size needed for a mean. So those you won't be able to mess up any of the boxes because they're locked otherwise. Alright, so this is the Excel file that I was talking about. It has a few places that you can type in. You can type in here in these 3 yellow boxes, and you can type in here in these 3 yellow boxes. Of course, in this case, we are looking at the sample size needed to estimate a population proportion. And so we're going to use these 3 boxes here. And the first thing I'm going to do is make sure I have the correct confidence level. So I want to have it be 99% confident, so I need to change that. I told I wanted a 3% margin of error. Now, if I put in a 3, we got to be careful because would you look at that? That says the sample size needed is 0.18. That's not even a person. If I needed one person in my sample, I'm never going to need one person in my sample. So this is, you've got to make sure. That means I want to be I want a margin of error of 300%. So we never want to put a whole number there. It even says, if you look down, I need to put 0.03 for 3%. All of the values must be entered as decimals, not percentages. That's very important. So my margin of error is 0.03. And then my sample proportion, I'm going to be 0.5 if I don't know, but in this case I do. So I'm going to say equals, and I'm going to put in the x divided by n. So 272 divided by 800. Now I have the sample size needed. Of course, again, just be careful, make sure you know, even though I have a number here that's less than 5, so 1,654 people, 0.300, blah, 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 that 0.03, that means I need part of a person. So if I need part of a person, that means I need an entire person. So we're always going to round up when the sample size calculation results in a decimal. So I'm going to say that we need a sample of 1,655 people. And actually, you know what? Not even people. I'm going to erase that. We need 1,655 16 to 17-year-olds. Because that's my population. One more thing about using this file, especially to find a sample size in order to estimate a population proportion, is that this sample proportion, the p-hat, if we don't know a p-hat value from, previous information, if p-hat is unknown, then we're going to use 0.5. Just saying, there's a 50-50 chance that they are or they aren't whatever the characteristic is. And the reason for that is because that will give us the largest possible sample size, regardless of the confidence level or the margin of error. If we keep our p-hat, our sample proportion as 0.5, that will always give us the biggest number. So that's just a little side note. This example didn't require that. We had information, but some of your homework may have it to where you don't know. So you want to use 0.5.